So in this lecture, so this is again the introduction to operating system. So here we will learn about computer system organization. So how is the computer organized? So computer system, basically it has what? So one or more CPUs. Your CPU is the central processing unit which executes your code, executes your instruction. So you have one or more CPUs. Okay, so they are the main workers who basically execute your instructions. So CPU, you can have one or more of CPUs. Then you have device controllers. Okay, they are also very important. What are device controllers? So you have seen in your computer, so you attach a lot of devices to it. So for example, you attach your mouse to your computer, your keyboard, your printer, your monitor. Okay, so these are the devices, your hard disk. So these are the devices that you attach to your computer, and because they have device controllers on those hardwares. Okay, so they are connected through the common bus provided access to the shared memory. Okay, so they are basically connect through the common bus providing access to shared memory. So we have a shared memory in our computer. So let's try to see that thing. So we have here a memory. Okay, so memory is shared. So memory is where you write which whatever is executed, whatever data you get from, let's say, your keyboard when you click something, mouse at some particular point. So all those things are noted and they give us some data. So they all through a common bus. Okay, they are all connected to the memory where they can store something, they can read something, and so on. So monitor through the graphics adapter, it is connected. So USB controller, through that you have your mouse, keyboard. Disk controller controls your disks, hard disk, how you access them. CPU is connected to memory. So computer system operation, so what they do, input output device and the CPU can execute concurrently. Now let's see this important thing. So your CPU can execute, your input output devices also, they also have their execution, so they can execute also code. So because we want our computer system to be efficient, what we do, we allow both of them to work concurrently. Okay, so each device controller is in charge of a particular device type. So for example, the monitor controller, that is in control of the monitor. Okay, each device controller has a local buffer. So for example, there is a keyboard and there is a keyboard controller. So this is your keyboard and there is a device controller here for your keyboard. So it also has a small piece of buffer. Let's say your computer somehow is busy, so keyboard can, whatever is being pressed, it can be stored in your buffer, and when there is a chance to send this data to the main computer, this can be sent. But a local buffer is important. CPU moves data from to main memory to from local buffers. So okay, CPU, what it does, so it has the main memory is there. Okay, so the memory or the RAM, what you call, and CPU can transfer your data from main memory to your buffers. Okay, main memory to your buffers, okay, of the keyboard, of other devices, and it can also copy from those buffers to its main memory. So for example, I press, let's say, AIO, these three letters, so they will be first stored, might be stored in AIO, will be stored in the buffer. Then your CPU will copy these from this buffer to the memory. Input output is from the device to local buffer of the controller. Okay, so then what happens, so this one, in fact, what I was saying is this one is local buffers. Okay, so the CPU also has some buffers. Input output is from the device to local buffers of the controller. So input output is from the device, so these devices, so they put it into the local buffer of the controller, device controller. So now let's see how it is done, what I was talking about. If there is a buffer here, the input output device stores the key pressed in from the keyboard here. Now device controller, it has to send it to the CPU or the main computer. So what it does, So I have to inform you. Let's say you are not listening to me, I have to communicate somehow. So here we use interrupt. So all these devices, they use what is known as interrupt. So interrupt informs the computer or the CPU that okay, some data is ready, you need to copy it. So this is basically being done by the interrupt. So device controller informs CPU that it has finished its operation by causing an interrupt. So keyboard device controller, when it has some data in its local buffer, it will interrupt to the CPU saying that please copy whatever I have to give you. So now interrupt basically is very important. This is the way for communication. Okay, so what are the common functions of interrupt? So interrupt transfers control to the interrupt service routine. So basically, let's think that I am a person, or CPU is basically a person, again the human analogy. So that is a person, and your piece of codes are basically some tasks that needs to be done when some different kind of interrupts come. So interrupt transfers the control to the interrupt service routine. So these interrupt service routines are the things that you have to follow when you get some interrupt through the interrupt vector, which contains the address of all the service routines. So basically, I'm a person, CPU is a person, he might get different kind of interrupts. Okay, so he can get an interrupt from a keyboard, he can get an interrupt from printer, he can get interrupt from a mouse. Okay, so there many different kind of interrupts can come, and then what happens, the CPU has different service routines or different pieces of code that needs to be executed when particular interrupts come. So what does the CPU do? He will see which interrupt is there, then he will look into the interrupt vector and find which particular interrupt service routine he has to run. Interrupt architecture must save the address of the interrupted instruction. So what happens? Let's try to understand this word by word. Interrupt architecture must save the address of the interrupted instruction. So he will save that instruction's address, and then what happens when the CPU is trying to run the interrupt service routine of for some particular interrupt, okay, then he need to disable all other interrupt. Basically what will happen, I am a person, okay, I was initially at my gate or a door listening to different people who are coming and interrupting me saying I need something. But when some interrupt comes, this person leaves the door, he goes into the house, does some work here, what was needed by that particular interrupt, and then returns back. But in between, when this person is inside the house and doing something to process that interrupt, the interrupts are disabled here, because otherwise if some interrupts come, he will not be able to know that they have come. Okay, so that's why it might be lost. So interrupts are disabled when interrupt service routine is being done. So now a trap is a software generated interrupt caused by either an error or a request. So software generated interrupts can also come. Let's say I write a very bad piece of code and do a calculation like int a is equal to 5 by 0. This is a very bad piece of code. It generates an error saying that division by 0. So that will be a trap kind of user software generated interrupt. And operating system is basically interruptive, and it's basically a person, okay, CPU. He is getting a lot of interrupts and he is handling all those interrupts. So he is getting one interrupt from keyboard. So I'm pressing some keyboards. Then what will happen? This interrupt, then he will try to write it to the monitor, whatever he is getting. So he will interrupt the monitor. So I hope till here this is enough for the second lecture on introduction to operating system. We will look at the third lecture for introduction to operating system. So thanks a lot.